Okay, perfect. Hey, good afternoon, everyone. Welcome back for part two of using AI with RPA. We did another the introduction session 2 days ago, and now we are trying to do the implementation and understanding how to implement AI with RPA. Uh, it's me, Ashish Nangla. I'm part of Accelerate, and I have Laurantiu with me. Laurantiu is a senior architect at Accelerate as well, and he has the experience of implementing multiple AI programs with typical RPA tools out there, and he's going to share most of the experience with us in terms of uh, how to do this integration, what are the typical challenges, and what are the typical use cases we see in this example. Okay. So as I said, today's session would be more about implementing how to go about implementing AI in RPA. We already did the introduction part, and now we are going to next session would be on 29th April, which is going to talk about the typical use cases and the problems and solutions out there. Okay. Uh, for everybody who attended or did not attend the introduction part, we have a recap, which is essentially what will lead us or give us a segue into the entire conversation about how to actually train and deploy AI and machine learning programs. So in this case, we talked about earlier. We talked about, or in the last session, we talked about difference between a typical RPA program and machine learning program, and the outputs of both the projects. Where in RPA you had more workflow and logic and definite set of outputs and inputs. In machine learning, we are talking about not a programs. We are not actually coding any logic. It's essentially learning from the experience or learning from the data that you already have, and then being able to make predictions along with that. In terms of what the I hear an echo, so I'll just go ahead and mute everybody. Okay, sorry. Um, so the idea for machine learning models and machine learning projects are you have input data. This also comes with the results from past experiences, which is what the outcome was or the result was. And then you use that for training models, defining various algorithms, looking at different data, and then testing that model out, and then using that for predicting. Okay. Then you give it when the model is completed, the development is completed, you would then give it new input which the model has not seen, and then you would ask for predictions, and it will give you that as an output. So if you see, that's the training part where you give it input data, where you are, and then you're building the model, testing it out, and using that for prediction. Okay. So keeping that in mind, what exactly we do, how do we go about doing this is what we define in the development process. So this is typical example of what an SDLC like project process would look like for identifying a machine learning or AI project, and then how do you go about actually developing it. So first is, of course, identifying the opportunity, and then there's about the preparation before you start modeling. Then you talk about the actual model development, and once the model development is complete, then you get into integration. So we will, of course, go into detail on each of these phases, and we'll go into each of the steps as well. Okay. So first part, of course, would be defining the opportunity and assessing the feasibility. There is a clear distinction between how you would go about doing AI projects versus or AI machine learning projects versus other software that you would generally deliver. First is, of course, some pointers are, you should consider human in the loop and always keep exceptions and reviews and supervision in mind on exactly how things will go and how the process would flow. and what happens when there are exceptions. So it's not just conditional exceptions. You would actually have exceptions built into the process itself, saying if the what happens when you cannot read the data, what happens when the incoming document, for example, is not what you were expecting it to be, and things. Again, remember that AI and machine learning are more subjective, so you don't get a yes or no or a rule set answer. It's more percentage probability of something, right? So you would say this is something that is this a spam email, right? It's not a yes or no, it's a spam email. Essentially, it'll say it's 80% probable that this email is spam. Okay. The other part is false positives and false negatives. So it's not just the straightforward answers. There's error rate that has to be built into when you do a typical a decision. It's just a yes or no. But in some cases, in AI and machine learning, you would have false identifications as well of data, of record, or things. So you have to understand what is the acceptable accuracy for your use case. In most cases, you have to see that it is something that you can actually deal with, is that and also understand what the human accuracy for that process or that particular task is, and you can define what the thresholds for those are, right? And that goes back to the part where you do have to have human in the loop, so that you can actually train and test the actual scenarios as well. The next part is looking at the biases. That AI and ML have been called out earlier for certain biases. Loans not getting, mortgage loans that are processed through AI. We have heard news about them being biased against or for certain set of people or certain demographics of people. Again, you have to look for policies and law or the legal requirements for automating such an such a business process using AI and machine learning. Um, there is explainability of models, but as you start using machine learning and you start going further and start using deep learning, explainability of models become difficult. Like for example, if something has identified a object as car in a picture, the exact reasoning behind how it was able to do that, there is some understanding, but overall how the model is learning and training, it becomes difficult for it to form under most legal infrastructure that is available today to explain how you came to that decision, right? If it was simple rules, you would have simply created a document saying these are the decisions that we take. But when it comes to AI and machine learning, those get difficult. So please look at your regulatory compliance and other policies as well. AI and machine learning are also subject to misuse. So be have a good understanding of how that can be misused. If the data and documentation is not sent in correctly or sent in certain fashion. Simple examples I see is license plate recognition. I have seen people selling merchandise which can actually tamper with that. So you could get into trouble for relying too much on that in such scenarios, uh, or relying too much on the technology in certain scenarios. So essentially, you are answering what is an acceptable use case and what is not. So is AI a good candidate? Machine learning is a good candidate for something like this. You have to look at the feasibility. Is that even possible with the data that you have or not? Okay. Of course, we'll take questions and answers later. The other biggest point with the feasibility of AI and machine learning would be what machine learning can do today for you. What technologies is really accessible? Can we do typical things like facial recognition and translation and things? Absolutely. Nowadays, everybody has heard that is used to play chess and board games like Go, and it has really, improved on that. We also heard that AI can generate art, and there are paintings out. There was an auction in which there was a computer-generated uh, painting, and that got sold as well. So I would say I'll rule that art is also AI, can also be done by AI and machine learning. Of course, there are scenarios where there is no human care possible with AI. Also, there's no we have not reached artificial general intelligence, which is what we were expecting, where you have robots that would do pretty much everything and understand what similarly what humans do. So those are the kinds of technology limitations, or I would say scope of technology in for machine learning and AI in most of these projects. On the left hand side is where we usually see machine learning being used for. Typically, I mean, there's multiple things you can do. If you focus on some of these aspects around scoring, classification, object detection, translation, document classification. These are good examples of what real life business cases are around you and can be used to do that. Okay. So once you have identified an opportunity, once you have assessed that the feasibility of such a project and decide to go ahead with that, so the first thing is preparing before you start modeling. There is a couple of things you need to do. First part is creating the training data, and this needs to be actual existing production data in most cases, and not just samples or not just fake generated data, because the models are going to learn from data. So you need to have actual real life scenario that you're going to use for training. Some of the splits that we do in terms of taking the training data is we split that into training set and testing sets, where we use say 5% for the script development and infrastructure development, for or pipeline development. 60% we use for actual training the model. 20% is where we use it for testing the models, and 15% is where we never show that data to any of the models and use it as if it's production, and do a final selection of the models. And the selection is also comes in because typically we don't go about testing only one or training only one model. If you know your use case very well and you understand the algorithms that are needed, you could choose one model. But in typical cases that we work with, we have seen that we land up testing or training multiple models and then making a final selection based on a preset criteria. Again, preset criteria would most likely be accuracy. So whatever yields more accuracy, whatever yields more results. Sometimes scalability is also a question. What happens when there's a uh, new class? What happens? There's a new document type. What happens when there's a new geography or language introduced? So sometimes those are criteria. Sometimes accuracy is the criteria, or sometimes both. So based on that, you would decide. Um, Training data. Then we get into pre-processing. So most of the times the data that comes in is not machine readable. It could be in email formats, or it could be in some other database formats that we need to make sure is ready for pre-processing, ready for machine learning. And the last part is making sure that before you train the models, you are able to label it correctly, which is essentially combining input data and the with the expected or what the actual output is, right? In this case, if you are doing samples on object detection, you're doing cars and bicycles, or traffic lights and objects on the street. You would basically go ahead and do that labeling, or have some kind of labeling available for the models to be trained. This could be manual, this could be automated, or this could be outsourced. We have seen all the three types. Uh, Next part gets into development, which is actually using various algorithms. We spoke about a lot of algorithms in the last session, and clear understanding of what kind of algorithms are available. And of course, that is the job of a data scientist to come in and do this part where you would actually take development and take the data, the training data, and train different models on them. Okay, it's most likely an automated process. You choose models. There are training methods. You call those methods and train those models. The output of the models are typically two things: is the model, the algorithm, and the configuration of those models. And the other thing you have is the actual weights and biases, or the actual equation that will be used. So those are the two things that you would use. That's the output of development. Again, as I said, there will be multiple outputs. You tweak those parameters of the models to run them again and again and see where you get better. Then you would start testing it. Once you have understanding of which models are fine, you would then test it. Test with the test data set, which is the 20% data set. You may go back to development because none of them actually solve the criteria, or you decide that that there could be something that can be done better. And sometimes you may go back to collecting new data altogether, because at the time of testing you realize that maybe your test set was too small, or you realize your test set was too biased around one set of results. So you have probably too many, when you're looking at loan approval versus rejection, and in some examples, maybe you have too many rejections, and you don't get to learn from the approvals. So you may go back. So this is actually a decision point where you will make sure that the development is correct, or at least passing the criteria that you have set. Then you come to selection. So again, what I said earlier, you would look at accuracy, and you can look at other parameters, and then select which model you're actually going to use for development, right? Or actual implementation. We can talk about deployment and integration. I would ask Laurantiu, who has more experience on this, to talk about this and give us some examples as well. Laurantiu, you want to take it up?
Yep. Hello, everyone. This is Laurantiu from Accelirate. So I'm gonna talk a few things about code review. Most organizations like you already have well-defined coding standards. This is like a topic that requires in-depth talk. It's a monster of its own. I'll just point out some of the things that are very important when handling a process. You want to make sure that all the code handles all the exceptions, everything that may occur. Errors are very well documented. Proper channels have been set up to handle all those cases where an exception occurs. You want to make sure the code is clean, easily debuggable, well documented. So if one developer gets pushed on another project, you want to have someone take over, and you want to have all the documentation ready. In the machine learning case, you might have external services. So you're going to have data contracts between the actual UiPath and the service that you're calling. You want to enforce those contracts because you don't want to have unpleasant surprises when you're like processing thousands of records a day. Some of the cases I've met have been even small variables that can mess up the whole project. So this is a very, very important step when making sure your package gets delivered into production. And on the packaging, this can come in like many forms depending on the solution that was chosen for the machine learning implementation. If it's a lightweight model, it can be distributed with a UiPath project, for example. This way you can keep the versioning same as the UiPath. If it's a self-hosted web service, REST API, then you're going to have another server or application on a suite of servers that's going to handle it. If it's a standalone distributed scripts, then each bot will have its own version of the model, same version. And here you want to make sure you have enough resources to run both the models and the bots, and make sure the instances don't cause collisions in case you have like high availability, high density bots cases. We had some cases when you were running two bots at the same time, but the machine learning can only handle one request. So you want to make sure, even if it's on the same machine, it's somehow scalable. When it comes to integration, it's again dependent on the deployment you choose for the machine learning model. It can either be a custom activity built in UiPath, and then you're going to have a developer, C# developer.
Yeah, sorry about that.
No worries. I'm going to get there. Or
we're running short on time anyways. It's like 7 minutes left, so
yeah.
Suffice to say, you have multiple options to deploy and these models. The interesting portion is you have to decide how they're going to run on each one of the on each one of the bots, whether you want to send the models. I think it's also interesting to understand, how you're going to do release management and the artifacts that are associated with an AI project, how they will be distributed across the environments as you deploy these models.
Most of the time you want to make sure it's a scalable solution. So if you need more resources, you just scale it up or down if you need it. That's pretty much what this slide is. It's all about. It's all the solutions that you have. And here we have a small case where the bot creates a support ticket. An email comes in. It gets routed to the machine model. Before that, you can actually pre-process the email and compare the incoming email with a database. So you extract company info, licensing info, or any other relevant data. Or you may even do a translating service on the email. Then it gets fed to the model, and you get a classification if it goes to financing or whatever groups you have for support. And this way, the robot can go in and open a support ticket, raise alerts, assign to different groups, queues, and I think that's pretty much it.
Yeah, I think we'd like to open it up for questions, unless you have more stuff. If you have any questions, you can just hit that chat button right there which says show conversation and enter any questions. Megan, do we have any there?
Yep, there's a few. So the first one says, how much data is required for training in a typical scenario?
My favorite question to Ashish. Go ahead, Ashish. Answer.
Okay, I'll take this up. So there are essentially two schools of thoughts. One is, you train the models, way in advance and start the actual application on a trained model, the bot on a trained model. And the other school of thought is essentially you start with no training at all, and then you start putting the design, you redefine the process, or you redesign the process in a way where the data can be made available more actively, because in some cases it's not as simple as here is the form of information we received, and here is a decision that a person actually took, or say a loan underwriter actually. It's not that simple. Sometimes you have to get more intense data and more specific information. In that case, you would re-engineer the process to make sure that you are able to generate that data and the model can be trained over time. And on the other side, how much data is available? So let's choose different models need different sets of or different types of data. If you're doing supervised learning, you need more data. If you're doing unsupervised learning, a little, not a lot. If you're doing machine learning, you need decent amount of information. But if you are doing deep learning, you need loads of information, loads of sample data. How much is a really a case where in different types of use cases, and how much of deep learning you are using, it depends on that. So our experience has been, anywhere between 100 to 20,000 record. So it's a wide variety, but it's basically essentially means that it depends on the use case and the types of model we'll end up using.
Okay.
Okay.
There's another question. This one says, out of the typical options that you shared in hosting the AI program slide, what option have you most commonly used or is the simplest to use with success?
The simplest we have used is the Flask hosted Python scripts. So basically you spin off a web server locally. Typically people have these web servers and you host your AI scripts as API endpoints, right? And it's fairly simple. All tools support that. All sorts of applications, if not the RPA tools, your typical .NET Java programs also support calling those APIs. So it kind of becomes an enterprise tool and not just, one-off use case.
Okay. There's one more in here. It says, how do you ensure data security when training data is from production with real customer information?
So yes, that is always a concern, especially because when we are training, we need to train on production data. So this is one of the unique examples or unique situations where you have to use production data for application development or by developers, right? So of course you need to make sure that you are passing the right data. Now you cannot change data to fake it, or you cannot have generate any kind of generated data or algorithm generated data. You need real data, actual and randomized. On some techniques that we really use is, of course, first is physical security, segregation of all these environments, keeping production separate, keeping development separate and things. But of course, making sure we pre-identify what is PII in that. And secondly, we also do binning where we don't get, age of a person. You can get the age group of a person and things. And of course, we don't use names and other information.
So there are a couple of other things, right? So that interestingly, we've used different approaches in different places where you have it's number one where you can't where you have to do model development in a development environment. One of the approaches we've used is to create the training scripts that you use some data to generate it to actually train the model, and then actually deploy those training scripts in production to use production data and generate the model. So the model is not generated in development, the model is actually generated out in the production environment. We've had cases where the customers had to make a decision whether do I want to pull all the data into a lower environment or just provide very controlled access to developers in the production environment where running the training script in production wasn't an option. So different patterns and different approaches. More than happy to discuss them in detail if you'd like to.
Okay. That was the last question submitted in the chat for this session.
Perfect.
Thank you.
Okay, I guess next session is on 29th April. We're going to talk about the typical use cases for AI. We will see you guys there. Thank you so much.
Thank you. Have a great day.